This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Rashan Senanayake.
What's up, listeners? Welcome to Season 4 of Inspiring Design with Rashan Senanayake. This is where the best of the best brands, experts, change makers, and thought leaders come together to share their valuable insights, experience, and knowledge, all centered around the growth sector in advanced manufacturing within Industry 4.0, encompassing various industries, technologies, skills, knowledge, trends, as well as stakeholders, all the while linking it back into education within schools and universities. Today, we're going to dive headfirst into a diverse industry where science, design, technology, and manufacturing meets to do some amazing things within the amazing world of orthotics. Sitting in front of me right now is one of the brightest minds within the orthotics industry, Dean Hartley. Dean, by practice, is a podiatrist of 15 years and the founder of iOrthotics and now ASX listed Healthier. Dean oversees the technology direction of Healthier in his key role as the Chief Technical Officer and guides the R&D direction of iOrthotics and Healthier through the newly formed R&D Hub. Over the course of 7 years, Dean worked with the University of Queensland, HP, and MyFootDr to validate the replacement of polypropylene with other 3D printed polymers to produce custom orthotics. More recently, iOrthotics was successful in receiving a $2.04 million Australian federal government grant for the research into the manufacturing and the use of smart orthotics. He's doing some amazing things and leading the way. So without further ado, let's get straight into it. Hi Dean, welcome to Inspiring Design. Can we start off with a little bit of background of yourself? What's your story?
Yeah, thanks for having me here, Rashan. Look, my background is I'm a podiatrist by degree. Studied in a country town, Albury, Wodonga, at Charles Sturt University there, graduated about 15 years ago. And it was treated in private practice, had a few podiatry clinics that I owned with a business partner of mine early on. And we sort of grew that business and one of those businesses, a part of the podiatry clinic, was actually iOrthotics, which is a manufacturer of custom foot orthotics. So podiatrists are commonly prescribing footwear or orthotics devices to go in people's shoes to sort of correct, walk-in and gait patterns. And that's sort of, I guess, how iOrthotics was formed, sort of through that sort of journey. The business has grown quite a lot to this day. It's sort of now been a part of the Healthier group. That Healthier group has about 300 locations of physio or podiatry clinics and that around Australia. My role in now is a Chief Technology Officer of Healthier and also a Director of iOrthotics, and I sort of still head up the R&D component of iOrthotics. It's been sort of my baby and my passion, I guess, for the last 10 or so years.
Yeah, wow. So it's one of those industries where obviously we're pretty familiar with all these foot issues that we have, but the actual work behind the scenes is really interesting, and that's one of the things I want to dive more deeply into. It combines design and bio and sciences and manufacturing, so marrying all of these industries creates a pretty interesting space. So can you tell us a little bit more about what is that industry all about? Like, is there a particular name, or is it an amalgamation of multiple, like civil engineering, which, for example, in-house, encompasses a lot of different types of engineering? Yeah. What's it about? Give us a little bit of high level.
Yeah, it's a good one. I think it's called the orthotics industry is probably what you would say. So that's the industry that manufactures typical orthotics. We're talking more about foot orthotics, I guess, from a podiatry space, but we also now make higher up orthotics like ankle foot orthotics and knee splints and guards and things like that as well. But look, if we just talk about the foot orthotic industry with it, it's quite a small, cottage industry, but quite specialised and unique, and a lot of it's from clinicians, practicing podiatrists that have gone off to then go, I want to specialize in manufacturing or making orthotics. So, to have an engineer or to, to have someone like that with those niche skill sets coming into this industry hasn't really been commonly done, because it's been very manual. It's been very hands-on skill type work, so lots of shaping and grinding and plaster casting and things like that. So it's a very unique skill set that would actually be involved in this industry. So it wasn't, although it's a manufacturing industry, it sort of probably wasn't in that space, if that makes sense. More of a supply to the podiatry clinics. Whereas with technology over the last, let's say 10 years, 15 years ago, that's when all the CAD type technology started to come, the CAM technologies come. So instead of everything being manually made by hand, using plaster, shaping, heat forming plastics or foams to create these orthotics or devices, now a lot of it's using CAD technologies to do all the design. 3D scanning can be done on your phone now. And then you implementing manufacturing techniques like subtractive manufacturing, so it might be routing, routing a piece of plastic out of a bigger block. 3D printing now, that's something that we've really strongly pioneered in this whole industry over the last probably 5 or 6 years. And even then software development as well to allow us to do all this. It's made our industry go from, I guess, just being very, very niche and just relying on just a skilled technician, a clinician, to now going, actually, you know what, I need that engineer skill set. I need that application development skill set, the CAD skill set. It's changed quite a bit. So,
do you expect your technicians or the manufacturers to have a level of science understanding, especially understanding the biology behind the actual mechanics of a foot, the engineer, or do you mainly rely that from the physio or the podiatrist?
It's a good point. Like, I think we actually try and train. So we have I'm a podiatrist. The general manager of iOrthotics, Scott, is a podiatrist as well, of 20 plus years experience. And we have a few other podiatrists or clinicians around the business, and we really instill into all our staff here. So we like to do just sort of some in-house training. So it's not just make that bit of plastic, It's like, why are we doing this? So because they commonly are dealing with prescriptions for patients that have been designed from a podiatrist or a clinician, and there's always that, well, why do I do this for it? So you sort of need to have the why and that around it. Otherwise, it just becomes very probably robotic and you're treating people at the end of the day and patients. So
100%. And obviously, coming from a design background myself, when there's a purpose behind what you're doing, and obviously the more you know the site or the product or the end user in mind, it becomes more custom and you actually do a better job overall. So it would make sense. And so one of the things I want to kind of understand is, if you mentioned that it was a skilled technician before all the technology came about. How long are we talking about? Like, when are there still people doing handcrafting?
Yeah, absolutely.
In Australia?
Yeah, there is. There's a few labs that that just sort of specialise in just doing that sort of still handcrafted one. But a lot of the probably labs here in Australia, orthotic labs we call them here in Australia and overseas, have really moved to a CAD CAM, a digital type of process, a somewhat digital process with it as well. But there's still a few out there that do it the very sort of manual, old school, I guess, way with it. We've always embraced technology in our clinics, but also in this manufacturing process for reasons. It's not just about improving the manufacturing process, but it's actually about getting, be able to create a wider range of devices. Using CAD to upskill our designers and our technicians, so it's not just relied on one person that can do one job, and if that person goes on holidays, then you just close the business and wait till they get back. So it's about trying to build out a whole new system, and we sort of call it a digital workflow, so that we can train multiple people, multiple areas, and then upskill and train our business. Because the reality is, you just can't get enough of those skilled technicians if you're just doing those handcrafted orthotics. It takes a lot of time to do. A skilled technician might be able to create 10 pairs or so a day, if they're really efficient. Whereas using digital processes, we can have one technician that could oversee maybe 30 or 40 pairs a day. So it gives that ability to sort of scale up.
Yeah, and obviously, while you were giving me a little bit of a tour of your facilities here, which is absolutely incredible, by the way, what kind of numbers, you shared some production facts about how much you guys actually achieve in a week or a month. What does that look like? Would you like to share some?
Yeah, we so I think we sort of normally talk probably a bit more in annual sort of numbers, but we make about 30 to 35,000 pairs of custom-made foot orthotics here a year with it. So every pair, every side of that pair, so a left and a right, is individually made. It's individually designed. It's individually in that finished as well. But we do a lot of other parts. We actually make orthotics for, because we specialise in 3D printing, we actually 3D print parts for other orthotic manufacturers where we just do the shell component and then they do their finishing and everything on their end.
Wow.
We've actually just, I guess, randomly expanded out a bit more into sort of more engineering parts or even hobbyist manufacturing, so people can log onto our website and actually just upload a STL file and get it 3D printed. We've got some pretty cool printers here, so people are sort of using that. So there's lots of other different sort of areas or different other, I guess, products that we now make as well, rather than just the standard custom foot orthotics like we used to do.
Yeah, and obviously it's evident that it's the implementation of tech into your industry that's allowed those scalabilities and then the different types of applications now you're doing.
Yeah.
Where do you think it's going to take you guys in the next, 20, 30 years? What do you think it'll be like?
Yeah, it's pretty amazing. I guess the example of us internally, we set up our printing facility in the US about 2 years ago, just before COVID hit. Worst possible time. I haven't been able to go back, but I'm about to book a trip to go back there with it. But so they do 3D printing over there, and I guess this whole industry 4.0 is sort of relevant in that, because it's now enabled us to use skill sets here, but be able to access a market over there, and so that's now enabled us to leverage that. So that's where the industry's going. It's not just relying on that one technician in the back of Brisbane. They can only service so much from there. They can't look at that global market really. Whereas digitising the workflow and leveraging our skill sets, we can. I think where it's going though in industry is technology's changed it so much. So we talked about like 3D scanning. So yesteryear it was always about you take a plaster cast of a patient's foot, to get a shape of that foot to make a custom-made pair of orthotics. Whereas now you can pick up your phone, if you're one of the latest sort of generation iPhones, you can get a 3D scan off that. That was, 10 years ago you were paying a scan of, paying the $20,000-$30,000 for a 3D scanner to do that for you, where now everyone's got that technology. And I think that's where it's going, is this consumer-led, the consumer now has the technology in their hands with it. So how do we sort of leverage that? People are wanting more custom-made devices. They want to put their branding on their own shoes. You can design your own shoes nowadays. You can... so that sort of customised healthcare, bespoke for that patient, is sort of where it's going. So we're trying to embrace that.
That's awesome. That's really cool, because and I think this is why the capabilities of the human generation, it's kind of gone exponential over the last decade alone. So
I think on that, as well, it's where it's going to change it, and I'm speaking to the broader is access to healthcare is changing because of that. Because if we talk about even we go to the end of the spectrum might be like some third world countries that don't have any health services, or not like we are lucky to have here in Australia, where they don't have a podiatrist or a physiotherapist or a doctor that could help them, and for us to help maybe
potentially more countries.
Correct. You'd have to physically go, right, I've got to get my podiatrist and send them, put them on a plane over there to physically see that patient. Now with technology, you can do remote teleconferences, and I said you can now take scans of people using a phone or an iPad or something like that. So you're now giving the ability to access healthcare in different ways that just weren't there before.
Absolutely.
Whereas before it was always just physical contact and interaction.
Absolutely. And I think COVID's context fast forwarded those things, just because we want to be able to be in the comfort of our own home or office or wherever, that little community, not have to travel a lot to get specialized equipment and I think helps sometimes. So you mentioned CAD, you mentioned 3D printing, laser cutting. What other tech is involved? Do you see any use of virtual reality, augmented reality, robotics, drones? Is that part of this industry?
Absolutely. I don't know, I didn't point it out when we walked downstairs, but there's in the corner there, we have a UR bot set up that's actually doing robotics, we've got this program in place at the moment internally, an R&D project where we're trying to automate as many of the different manufacturing processes as we can, just to reduce that sort of human error, increase the quality control, the throughput, again, gain those efficiencies. So we have a robot downstairs that we've now worked with the University of Queensland very closely on, is to actually identify different parts, because we have a left and a right normally in our parts, so they can actually find them, pair them up together, sort them, and actually put them into that manufacturing chain. So we're actually using robotics in different areas of our manufacturing flow now. So yeah, it's going to happen. Absolutely. Awesome. So, and it's working alongside of our technicians. People always say, you're going to replace humans. Like, no. It's all about making them more efficient.
True.
So then you can go, well, they, instead of them getting done, I said before, like 30 to 40 pairs a day, maybe they can get 50 pairs done a day when they can automate some of those processes that they're still having to manually do. So that's what our goal is to make our staff and our business as efficient as possible.
Yeah, and obviously I think one of the these challenges that people usually assume with automation is job loss. And it naturally comes, because we're going to be automating the existing mundane tasks, but that doesn't mean the human control and the next level of creative thinking or critical problem solving or the human involvement is still there. It's just evolving and changing into something new. How do you see the value of that? How do you see the importance of creativity? In our context, we call it design thinking.
Yeah.
How does that play a role within your context?
It's sort of it's everything that we're doing, in a sense that
I love that, actually. Everything we're doing, that's perfect.
Well, it's I'm a podiatrist, so 12 years ago when we started, I thought it was just, maybe we can manufacture some of these devices internally. Yeah. And I was very I'm tunnel vision, because this is how I see the world. This is how I see the manufacturing process happens. How you make a pair of orthotics. You bring an engineer in. You bring a data scientist who is looking at all the numbers. You bring a CAD engineer or a CAD developer in. You bring an application developer. We have like 3 sort of web application and developers on staff now that are doing our web portals and our QMS and that. And they look at it all differently. So they'll challenge our thinking. The clinicians in the business going, hang on, why do you do it like that for? That's silly. That doesn't make sense. And you're like, well, it doesn't actually, but that's the way we've always done it. So then they go, well, maybe if you design the part this way, you'd actually be able to increase your efficiency downstairs when you're actually finishing that part. So it's looking at things in so many different angles and lights, not just from this clinician's point of view, which is what this industry, as I was sort of alluding to at the start, has always been looked at.
Yeah, I love that, because that's like actually a true example of a collaborative environment, like multidisciplinary context, different points of view, actually working towards the same goal because you're in the same place. So that's great. Now, let's talk education. One of the things that I always bring each industry back into is, how does this connect with the secondary and the tertiary sectors? What do the skills pipeline look like? How are our students, the future context of people that might be interested in this industry? Do you think the school system and the education system is currently aligned? And if so, how? If not, what do you think we should do?
Good.
It's a tough one.
It is, and look, I think I'll start with, we've always been very open to have, the secondary schools or the tertiary students and that come through, have a look at what we're doing whether it's just to, pollinate some ideas or, to get them thinking in a different light, to see what's actually out there. Why am I learning my, maths and science subjects at school? What's it actually going to do for me? And it's like, well, this is where it goes to. I think, the gateway to industry for school. So that's the program, is it? Yeah.
Yes.
Gateway for industry. The schools program. We've always been somewhat involved in that, in having quite a few different tours and around our facility to help with that. And I can see that there's a lot of effort now put into those types of program, which I think is needed. But I think as an Australian sort of economy, we need to invest in those skill sets. We're never going to compete with a China in sort of manufacturing raw materials, with it. But what we can compete on is that quality and that skill set. And that's what we need to really foster through our tertiary and our secondary educations, even from primary. My little daughter, my eldest daughter, she's 9 and she's about to start like a coding workshop. I just love it, just doing things like that.
That's cool.
Whereas going to school, I never did anything like that. We're lucky to have a computer, whereas now they're actually learning to do that. So you can see the curriculum from afar is starting to change and to lend itself so that they come out of school looking to to study these different areas, which I think is great. We feel like we have a bit of responsibility to never say no to when students want to come in and have a look around. We've probably had a dozen engineering students work within our business over the last 2 years now, doing their commercial placement. So they've got to go on site for up to sort of, I think it's 200 or 300 hours of a placement as a part of their degree.
Right.
So we get them to come in and actually they'll work on the printers, they'll work downstairs on some different robotic projects. So we really sort of never say no to that, because that's where we see the the future is for us.
There you go, guys. So if you're listening, definitely reach out from an educational perspective. Dean's demand for the job. What are the skill sets that you're looking for, especially from students that are interested in this type of career, this type of learning as their profession? What do you think are the key skills that are required for their success in this context?
In this context, I think there's always, problem solving, critical thinking is always the one, because we're not just here going, there's, 1 + 1 = 2, you get thrown all these different equations at you each day, and I think it's critical thinking, taking that initiative as well, with trying to problem solve is a big one, and not just always going, oh, this is the way it's always been done.
And that's why you love the guys when they question from their point of view. Yeah, absolutely.
Yeah, I always find it, I might be saying the wrong thing, but I always love when the staff will go, we're too busy, we need more staff, and it's like, okay, just stop for a second. I hear what you're saying, but can we just stop and think, okay, where's the bottlenecks? Where are we falling down? Well, we don't have, we're in a bottleneck at the machines and that with it. It's like, well, why don't we do we need a new machine out there? Or is there a new efficient way of actually doing this process with it? So before you sort of come to it just with get more staff or invest in this, actually go, well, how can we improve the process? If we've exhausted everything like that, we just need more bodies or need machinery, that's fine. But is the process itself actually... is that being actually, as efficient as what it can be?
Absolutely. And I think it's as simple as sometimes taking a step back and looking at things from a bigger picture rather than just jumping into that reactive conclusion. And this is one of the things that keeps coming up when you're going through that critical thinking, creative problem solving. You can't jump into ideation immediately just because you have a challenge. You got to take that time to actually empathize, work through things. And I love that. That's great. Yeah. What's your advice for students if they're interested?
I would say just learn as much as what you can, experience as much as what you can, go and do your work experience. I remember going through school doing some just random work experience for different places when I was in grade 10 or 11 at school, and just experiencing different industries and try and sort of find your passion. I think it's sometimes hard, and that's why I bring it back to my family. I always try to support my kids to try just different things, whether it's a coding workshop or it's play this different sport or do whatever. You've got to actually just try it and you'll find your passion. I think though, if you don't, I think your skill set probably lies where your passion is probably. If you're really passionate about something, because then you'll be motivated to learn more, you'll be motivated to study, you'll be excited to go to work in the morning. So
that can actually happen, contrary to what social media might say. So yeah.
Correct. I think if you don't find that, that passion or that, you sort of, you're barking up the wrong tree, I think.
Absolutely.
Well. So you got to find that. So and I think the only way to do that is experience a lot of different things.
Yeah. Love it. And one of our core clientele is teachers. It's one of their, in my point of view, I think teachers are the most undervalued in Australia.
Absolutely.
By far. Other countries leading education have figured that out, and they're treating that context and education in a very different way. So I always, every single episode, make sure that I ask our industry professionals and leaders, what advice do you have for the teachers? Because they're the ones who hold the responsibility of the student, and they're the ones who kind of have to know the technology, and they have to translate it into that student's mindset, which is not an easy task. What's your advice for them?
Yes, I don't know if I don't think I've got an authority to say anything, but I guess when I look back at some of the teachers that I had through my university days, and that is, I'd say that just always, it's a continual learning journey. And the teachers I look back where I thought were maybe a bit, whatever you'd say, stale, or the ones that were doing the same, you could see them just had their same lecture or
and you were able to
plan.
connect with them.
Yeah, and you want them to. It's more that you want them to keep on learning, with it, so that they're. I think you said it good before, Sean. Like looking at the new technologies, looking at the new industries that are out there. Because if they know that, then they will feed that to the students. Because the students look up to them with it. So they've got to keep learning just as much as what the students beneath them do.
Absolutely.
Especially this game. I mean, we're talking sort of technology, design. Like this is changing. This is not mathematics that's been the same for the last however many centuries with it. This is evolving every year. There's a new iPhone scanner that's come out. There's a new way to sort of manufacture these devices. So they've got to be on top of it.
Love it. Absolutely love it. So last but not least, do you have any resources, or if anyone's interested in learning about the orthotics industry, where can they go to check out more information? Yeah,
probably a good place to start what we do is just to go to the iOrthotics website. So iOrthotics, that's the letter I and then orthotics.com.au. On there, you'll see there's some few videos there around sort of what we do here as a business. It's got a few videos around tours around the site and some of the sort of key areas like sort of technology, sustainability, that we sort of focus on as a business and that here. So that's a really good place, I think, to start, just to see what we do.
Yeah.
And then that would probably, push
branch out
into the industry.
Perfect. Make sure you guys jump onto the show notes and check out those links directly as well. So, Dean, thank you so much. I know this is a small little conversation to a very big and cool industry, but I think it gives a very informative, high-level choice of what it's all about and how people can take those learnings and excitements to the next level. But thank you so much for your time.
No worries. Thanks, Sean. Thanks for having me.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto rashansenanayaka.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Rashan Senanayaka. Till next time.